Often in programming, we have to do the same kind of task multiple times. So now we'll talk about repetition structures, otherwise known as loops, and in this part, the condition loops. So being able to loop through a task multiple times is part of what makes software so useful. Computers can handle repetitive tasks for us, such as keep processing this work until it's done. With an if statement, we can ask a question, and then if that question is true, we do a command and then continue on with the rest of the program. It only does this one time, but it can be useful to ask a question and do some special code for that condition. With a while loop, it'll be structured very similarly. Instead of if question, we'll say while question, but the difference here is it will do some special code if the question is true, but it will keep looping over and over and over until the question becomes false. Then it will continue with the program. So as an example, here's a little program where we set age to 13. If age is less than 18, we say can't vote. It only outputs one time. If we change this to a while loop, though, it will loop this forever. We have created an infinite loop. So they work kind of the same way. They look kind of similar, but the while loop will continue looping forever unless we, in some scenario, change the condition to evaluate to false. We're not changing the condition itself. We're manipulating the variable it's looking at. So eventually, if age is 18 or 19, 20, something above 18 or equal to 18, then it will not execute the while loop. It will leave it. So to fix this, so the condition is always true, so this will loop forever. In order to fix this, we'll need to have some code inside of here that will eventually make age no longer less than 18. So if we can get age to reach 18 or something above it, we will not be stuck in an infinite loop anymore. So if we modify this so that we start at 13, and each age, we display the age, can't vote, and we add 1 to the age each time, then eventually we'll get from 13 to 18, and eventually we'll get down here and exit the while loop to where we can vote. So it'll go 13, 14, 15, 16, 17, 18, and it will stop there. So every time through the loop, it'll say age is 13 less than 18? True, 13 is less than 18. Display the age, 13, can't vote. Age equals age plus 1, so now age is 14. Once it gets down here to the bottom of the inside of the loop, it comes back up here, checks it again. Is 14 less than 18? True. Can't vote. Age equals age plus 1, 15. 15 less than 18? True. Okay, can't vote. Age is now 16. 16 less than 18, can't vote. 17. 17 less than 18, can't vote. 18. 18 less than 18? False. So then it exits and comes down here and continues on with the program. So since this condition right here, the question is looking at the age variable, we will need to make sure that inside of our loop, the age variable eventually causes this condition to evaluate to false. So by getting it outside of the range of less than 18, it will eventually quit. It'll loop a bunch of times, but then eventually stop. If this weren't inside the loop, it would not fix the infinite loop problem. If this was out here, it wouldn't do anything. It has to be inside. So once the age reaches 18, or if we were adding by 2 each time, if it reached 19 or something greater than or equal to 18, it would eventually stop. Oh, I think I accidentally duplicated that slide. So the pseudocode is going to look like while some condition, and then we do some statements, and then out here, once we unindent, is when the end of the while loop is. Each time we go through all the statements inside of the while loop and return back here to evaluate the condition, that's known as one iteration. So right here, if we had age 13 less than 18, do this, and come back up here, that is one whole iteration. So one iteration is one time through the loop. So here we have the question. If it's true, do something, and then it comes back up here and reevaluates the question, and that loop continues until it's false. Then it continues through the thing. And note that sometimes the flowchart can look like this. I like to make it just point directly back to the diamond, the question, but sometimes you'll see it where it comes back to the arrow right above the question. Either way, it's going to come back to the question, re-ask it again, and keep looping in some direction. There are some other types of loops that we won't really be looking at it in code, though C++ does have this one in particular. We can have a do while loop, so we say do this and this while the condition. So what this does is it is like a while loop, except these are executed at least one time, no matter what. So it does this and that, checks the condition. If the condition is true, it's going to loop back again. If the condition is false, it's going to continue on with the program. It only executes this once. There's also the do until loop, but Python also doesn't have this. I don't think C++ or Java or C# have this. At least I've never seen it ever used. But the idea of do these statements until we hit a condition. So instead of loop while we hit this condition, while this is true, we say do this until a condition is true. So it's kind of the opposite. Loop while true, do, and then stop when this is true. But since we don't have this in Python, we're not really going to worry about it too much. Okay. So let's practice. I know while loops are still pretty new. I am going to have a talk on common applications of using loops and if statements to kind of tie everything together, but at least we can get some practice in and you can see how I will implement these. So these, I think I have 4 examples and I accidentally closed that. Try to write some pseudocode or a flowchart or some Python code for each of these programs. So for this first one, write a program that uses a while loop to count up from 1 to 10, displaying each number to the screen. So to think about the design, first you'll need a variable to keep track of a counter. We're starting at 1, we're going to end at 10. What do we initialize the counter to? Then we'll also need to write a condition for a loop that keeps the loop code running until we reach the end at 10. So what is the condition that gets the loop to stop once we reach something above 10? And then inside the loop, we'll need to display whatever the current value of the counter is. And we need to make sure the counter goes up by 1 each time. So go ahead and pause this video, work on one of those, and then when you resume, I will show you the flowchart and we'll do the code as well. Okay, so let's open the diagramming tool that I like to use. We're going to create a while loop that counts from 1 to 10. So first off, I need a variable. We'll just name that counter. And I'm going to initialize it to 1. This is our starting value. And I guess I should put start program here. Okay, so we'll start with this counter. And we want to count up until some max value. That will be 10. So we'll have a question. Is the counter less than 10 or less than or equal to 10? If it is, we're going to keep displaying it to the screen and counting up. So is counter less than or equal to 10? That's the end point. If that's true, then we need to display the counter to the screen. So we can say, hey, it's 1, or hey, it's 2, hey, it's 3, so on. If it's false, we basically end the program at that point. So we'll just put this down here for the time being. I have a cat in front of me, so it's harder to type. So we display the counter, but then we need to make sure the counter goes up by 1. So we'll say counter equals counter plus 1. It'll go up by 1 each time. And then we will return to the loop. and then it will evaluate it again. If the counter is not less than or equal to 10, basically if it's greater than 10, then we will end the program. So it'll count up. So let me make a little variable. We'll say counter is equal to 1. Let's change this color so it's a little bit easier to track. Counter starts at 1. Is 1 less than or equal to 10? It is. I should have put some labels in here. This is true. And this is false. So counter, display counter 1 to the screen. Add 1 to counter. Now it's 2. Come back here. Is 2 less than or equal to 10? It is. Display 2. Add 1. 3. Is 3 less than or equal to 10? Yes, and so on. And we will keep looping until eventually we get to 9. So for instance, we add 9. 9 is less than or equal to 10. Display 9. 10. 10 is less than or equal to 10. Display 10. And then finally we get to 11. Is 11 less than or equal to 10? No. So then it comes down here and ends the program. So let's keep that right there. And we'll write it in Python as well. We'll set counter equal to 1. While counter is less than or equal to 10, we'll print out the value of the counter. And we'll, well, there we go. We'll say counter is equal to counter plus 1. And over here, we'll just say end of program. I have to move this cat. I can't type it all. Sorry, Luna. Okay, so we can run it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. End of program. Okay, for the next one, write a program that will ask the user to enter a number between 1 and 10. If they enter an invalid number, have them re-enter their choice. Don't continue the program until they enter a valid option. Display their choice at the end. So in this case, we're getting the user's input and we're basically not letting the program continue until they enter something valid. So we'll need a variable for the user's input. We want to write a loop that will say continue looping while the user's input is invalid. We have a range. 1 to 10 is valid, so less than 1 is invalid. Greater than 10 is invalid. And we can use the OR logic operator to check this. How do we get the user to re-enter their choice if they choose something invalid? So we can do another input with that. So in this case, let's go ahead and erase those. We'll have the user enter a number. So let's just put display enter number between 1 and 10. Okay, we'll get the user's choice, get user input, store in, let's just say choice. And now we check if it's invalid. So let's start by putting a diamond, is user choice invalid? And I will extrapolate on this in a minute. While it's invalid, we want them to re-enter their choice. Display invalid choice, try again. So it'll go over here, it'll go down here. And when they enter a new choice, we have to reevaluate it to see if they have entered something valid this time. Otherwise, if they entered something valid, or basically, is user choice invalid? If that's false, it means it is valid. It's okay. Display choice, and then the program ends. So in this case, this would be false. But we can't really write this as the question. Is the user choice invalid? The program doesn't know if it's valid or not. We have to specify what makes it invalid. It's valid if the choice is greater than or equal to 1 and choice is less than or equal to 10. But we're not checking that. We're not looping while it's valid. we need to loop while it's invalid. So the invalid option will be the logical opposite. While choice is less than 1, or choice is greater than 10, while it's less than the minimum or greater than the maximum. So instead of writing it this way, we'll say choice less than 1 or choice greater than 10. If that's the case, we will display invalid choice, get them to re-enter it, and continue. What this will look like, say choice equals int, input, enter number between 1 and 10, while choice is less than 1 or choice is greater than 10, we'll say invalid selection. Then we'll get their choice again. So I'll just copy and paste it from here. And then at this point, they've entered a valid choice, and we can display it to the screen. So when we run this, enter a number between 1 and 10, let's say negative 250, positive 250, 10. Choice is 10. That was valid, so it's letting us go. Let's continue. Okay. Practice number 3. Have a program that continues running until the user decides to quit. So they'll actually have to click on a quit button, or really not click, we're not using buttons, but they'll select a quit from the menu. Oops. But otherwise, the other menu options will be like, what is my name? What's my favorite color? What's my favorite game? When the user chooses one of these, it'll display that and then come back and wait for another choice, so they could like go through the entire list. And then once they actually choose quit, it will then end the program. So we'll need a variable to keep track of the user choice. We'll need a loop that will continue running until the user decides to quit. And we'll need if statements inside of the while loop to handle this part, displaying name or favorite color or favorite game. Go ahead and pause, and I'll go through the solution in a moment. Okay, so over here, let's look at this. Start the program. Oops. We'll start a loop, but we need to have something like a user choice. So let's just say choice, we're starting it at 0. Doesn't really matter, but we need to have choice in order to create a loop based around that choice. If we didn't have choice already declared, we wouldn't be able to do a conditional statement on it. So we could say, while choice is not 4, if we're going to have 4 as the quit one, so what is choice equal to 4? Then if that's true, we would want to quit. If that's false, we don't want to quit. So in this case, we'll just put program end. We can put the true at the bottom, or we could put the true at the side. I am going to put true pointing this way. Now in the other examples, I had true pointing to the right, so just keep that in mind. If it's true, we are quitting. Otherwise, we are going to run the program. And so we start choice at 0. It starts at 0 is not equal to 4, so it's not going to run this yet. So if choice is not 4, we do the menu. We'll say 1 name, 2 game, 3 color. I don't remember what order they were in. I think it was color and then game, but we can order this in either way. We'll display that to the screen. Let me just say display. We'll get the user's choice, get user choice, store it in something called choice, I guess. And then we'll need another diamond. So this one's going to be for a loop. This is a loop right here. We haven't finished writing it yet, but the internal one is not a loop. So is choice 1. We could have choice is equal to 1, or we could have choice is equal to 2, or we could have choice is equal to 3. So these would be if, else if statements. We don't need to check for 4 because technically our loop already checks for that. So if choice is 1, we will display whatever that is. So display Rachel. And we'll point that there. This is the true condition. If it's not 1, then is it 2? If it is 2, we'll display a game. I'm looking forward to Legend of Mana being re-released. And if it's not 2, then is it 3? What's a color? Display purple. So we have these. Once these if statements have executed, we will continue to run the program. So let me just finish labeling these real quick so that's clear. False, false, and false, or if this is true, they're going to converge back. So it displays one of these, and I'm gonna just put kind of a little thing like continue program loop. Even though this doesn't have any code associated with it, we're just putting this here as a nice little place to kind of converge everything back. So I'm gonna make these clearly point to this. Once we're done displaying a favorite game, or a favorite color, or a favorite, well, or a name, I guess, then we continue with the program. I don't know why that keeps displaying like that. And this comes back to the loop. That's not very nice looking. Let's try this. Nope, that doesn't look good either. I'm just going to use a normal straight arrow. So this is basically the program itself, and then we just have a special loop that continues looping while the game or the program is not done. I know this is very confusing in a way. It's not very linear, but a lot of programs, you'll need to keep them running until the user selects the quit option. So most of your program will be written inside the loop, and then these are the features you can choose in there. So let's look at this in Python. Okay, so we'll start the program. We'll just say choice is 0, and we'll have a loop while, and actually, this is kind of phrased badly. Let's see, if choice is 0, we want to end, but actually if choice is not 4, then we want to continue looping. So since we're doing a while loop, it has to kind of be a positive. So while choice is not equal to 4, then we'll print the main menu. We'll get the user's choice. Oh, I forgot to display number 4. If choice is 1, we'll display Rachel. Else if choice is 2, we'll display Legend of Mana. Else if choice is 3, display purple. And we could have a choice is 4, but we're not really required to do that because the while loop will detect it. And then back down here, I'll just say goodbye, because this is the end of the while loop. So the main program continues running. We can ask the user for multiple selections. I could put this menu here, or I could put it beforehand, so it'll ask me the menu every time. But if that doesn't look good, we can throw that up here and just ask for a new choice each time. And we'll add a new print. So run. choice. 1, 2, 3, 4, and then it quits. So we'll have some more chances to write little programs like this where it'll continue doing some sort of operation until we choose to quit. That's an example of doing that. The continue and break commands are also kind of useful to have with our loops. So let's say we were writing a program that did division between two variables, a and b, but sometimes b might be 0. We don't want to have any divisions by 0, so we'd want to detect that error and skip it. So normally this is just going to loop. It'll stop once a is less than or equal to 0, but if b becomes 0, we want to handle that in some way. So in this case, we can use the continue command. If b is equal to 0, we continue. And what that does is take the program flow and move it straight back up to the while loop top. So it will come back up here. It will not execute anything below it. And it lets us kind of skip a situation we don't want to process. Or we could use a break command, and the break command will let us exit the while loop immediately. So it won't go back up here and continue the loop. It will stop and continue the rest of the program. So I'll show you some examples of using this. Let's say we're going to write a program that will ask the user to keep entering how many cookies each child has. Or if they enter a -1, we'll stop counting altogether. That'll be kind of the signal that we're done. At the end, we'll display the sum of all of the cookies that the kids have. So as a diagram, let's look at this. We are going to need a sum of cookies, and we're going to need a variable for how many cookies a individual child has. So let's do program start. Let's set sum to 0. That's the amount of cookies that we have been adding. We start at 0 because we haven't added anything yet. So we will say while true. We want to continue looping forever because we don't know how many cookies there are. We're just going to let the program continue running over and over and over until the user types -1. So we'll basically say while true, or while the condition true is true, which is always, it'll keep looping. So in this case, false never happens. There is no false. We can't turn true into false. Doesn't exist. That's okay. We will manually break out of this. So during true, when this is true, which is all of the time, we're going to ask how many cookies does a specific kid have. So let's say get user input store in cookies, like one amount of cookies for one kid. Maybe they have 2 cookies, maybe they have 3 cookies. And then from there, we will add that onto the sum. So sum is equal to sum, whatever it's currently at, plus this new amount of cookies. Okay? And then we loop back up here. Now I'm not done yet, but this is the loop. This, though, is going to loop forever, and we want to be able to say #1 to stop counting any cookies. So we're going to have to add something else. We're going to have to add an if statement, another question. If cookies is equal to -1, then we quit. Otherwise, we are going to add it to the sum and then keep looping. So this is going to be false. If cookies is not -1, then we keep adding on. But if cookies is -1, then basically we're done with the loop. We're leaving the loop part. We're going to display sum and then into the program. Like that. And in the code, we'll set sum to 0. We'll say while true, And basically this is going to execute the break right here. And so that continues the program running. So we leave the loop. While true, we'll say cookies is equal to int input how many cookies for this child. We'll add that onto the sum. But we need to check for that exit case. If cookies is -1, we are going to break. We're going to exit the loop. And down here at the end, we will print total cookies and the sum. So we run this, let's say we got 5 to, different values, and then -1 to quit. There are 21 total cookies. Okay, another example where we can use continue. Let's say we're writing a little voting machine and it asks the user their age before we let them vote. If they happen to choose an age that is under 18, we're going to skip them and basically go to the next person. So we want to have 10 total votes. They can choose cats or dogs as what they're voting for, and we'll keep a track of how many votes for cats versus how many votes for dogs. So in here, we'll just start by saying cat votes is 0, dog votes is 0. We're kind of initializing it. And we can say how many times have we gotten? Total votes will just be 0. How many times has votes happened? We can keep track of that. While total votes is less than 10, because we want 10 total votes, we'll say age. What is your age? If their age is less than 18, then we're just going to continue. So it'll continue looping. Let's just go ahead and say you're too young to vote. It'll continue looping. It's just going to skip this one person. So down here we can put the rest of the loop. We'll say vote for one of the following. Oops, there we go. Print 1 cats, print 2 dogs, and we'll say choice is equal to int input your vote, and we can add an if statement. If choice is 1, we'll add to cat votes. Cat votes equals cat votes plus 1. Else if choice equals 2, we'll add to dog votes. And either way, we will add to total votes. Now, something we might need to think about is that what if the user types in 3 or 0 or something else like that? Well, we could have our input validation to make sure that they choose one of these two options, because otherwise we'll just have a bunch of empty votes if they choose the wrong thing. So let's go ahead and do input validation. If we can say if choice is not 1 and choice is not 2, they've entered something invalid. So we can get their choice again, and I'm going to add a statement to say invalid choice, please try again. So then that means we're forcing them to enter 1 or 2, and then we can vote properly. Let's say print at the end, cat votes, dog votes, and then we'll run that. What is your age? Okay, let's say I'm 18. I can vote for cats. And then I'm gonna make this a little nicer looking. We'll just say print new lines. What is my age? 17. Too young to vote. What is your age? I'm gonna put this at the top. I just like making this look a little bit nicer. Okay, 17. Too young to vote. Okay, 19. Gonna choose cats. 30. Gonna choose dogs. 56. Different things. So this is going to loop until we have 10 total votes, so we'll just kind of set these. I can do 4. It'll say invalid choice, -2. Oh, it let me do that. That's weird. I see. I messed this up. This is supposed to be a while loop and not an if statement. That's actually a common problem. So if I have an if statement, it will only check invalid input one time. If it's a while loop, it will continue not letting me move forward until I have entered everything. I'm also going to put print total votes out of 10. Total votes out of 10. So we'll say, what is your age? 19. Cats. 30. Cats. 40. Cats. And so on. If we say 5, you're too young to vote. We're skipping you. Okay, how about 20? And I'm going to choose negative 52. 50. It won't let me do any of those, so I can choose one specific one. And I hit a button on my keyboard or my mouse that caused me to lose whatever I was doing. Okay, we will try that again. I'm going to make this number smaller. And we'll just say we need 3 votes instead. Run. So 30 cats, 20 cats, 1 too young to vote, 80 dogs. And then here's the end, cat votes and dog votes.